Lesson 9, Capacitor. This lesson will discuss the basic operation of a capacitor. What is a capacitor? A capacitor is a two-terminal component represented by this symbol. Two horizontal lines in parallel. The basic operation of a capacitor is that it stores charges, almost like a battery. However, unlike the battery that already has a stored charge, a capacitor doesn't have a charge at first, and it can't replenish the charge once it is discharged. To give it a charge, it should be connected across a battery. It will charge up until it reaches the same amount as the voltage of the battery. Now, it has the same 1.5 volts of charge, and this charge will remain until it has something to discharge to. In time, however, real capacitors discharge by itself. Larger capacitors are able to retain the charge longer. Consider this sample circuit. If switch B is turned on, nothing happens to the bulb because the capacitor isn't charged yet. To charge it, we must close switch A. The capacitor, as you have already learned, will charge up. By changing the states of the switches, it now has a load to which it can discharge, and then the bulb glows. But then, notice also that it goes off almost instantly. This happened because the capacitor quickly discharges to the bulb. For a short amount of time, the capacitor acted as a battery. Capacitance. The ability of a capacitor to store a charge is called capacitance, and the unit is called a farad. 1 farad, however, is already a pretty high value of capacitance. Typical capacitance values used in electronic devices are several orders of magnitude smaller than a farad and range from a picofarad, or 1/1,000,000th of a farad, to a microfarad, or 1/1,000,000th of a farad. In microelectronics, capacitance even smaller than a picofarad are used. Classification. Capacitors can be classified as electrolytic and non-electrolytic. Generally, electrolytic capacitors can store charges larger than what non-electrolytic types can do. They are also larger physically, but one major characteristic that distinguishes an electrolytic from a counterpart is that it is polarized. By this, it means that it has positive and negative terminals. Thus, proper connection must be observed, as connecting an electrolytic capacitor the wrong way may cause it to explode. Let's further discuss the construction of a capacitor and how it gains the ability to store a charge. Its symbol basically summarizes its construction. A capacitor is constructed by separating two flat conductors with an insulator. In capacitor terms, the insulator is called a dielectric. This construction doesn't allow current to pass through. Thus, this results in a buildup of positive charges on one plate and negative charges on the other. As the opposite charges attract one another, removing the battery will still make them hard to get out from their position, thus leaving the capacitor charged.